Hello, good to see you again. Welcome to Block 5, Fraction, Decimal, and Percentage Equivalence, Lesson 15. I'll share my screen. Let's move this out of the way. Okay, so in your previous lesson, you learned how to convert fluently between fractions, decimals, and percentages. I hope you haven't forgotten about that so soon. In today's lesson, you're going to learn how to work with fractions that are above 1, decimals and percentages of such fractions that are above 1. And this lesson is the end of term 1 block of learning. So term 1 of year 7 block of learning covers block 1, block 2, block 3, block 4, and block 5. So well done for sticking around and for improving your understanding of maths. I will encourage you to move on to spring term 2 of year 7, where you can further deepen your understanding of the fundamentals of mathematics. But before we proceed, I would encourage you to help us grow our mission to educate children around the world, regardless of their financial situation. So, to do that, the favor I'm asking of you is to like the video, subscribe to the channel, and share the video to people or children you think might benefit. You could also do them a really huge favor by providing them internet access if they do not have internet access. That is the next level we're going to be working at, to make sure that everyone has access to high quality education regardless of their financial circumstance or where they're born or where they grow up. But we'll get there someday. All right, let's proceed. Before we get started, I would like you to answer the retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. So for the first one, the answer is 7/12. We can see that we have 12 boxes, but 7 boxes are shaded. So the fraction represented by this diagram is 7/12. For B, we can see that we have 5 boxes, but 4 of them are shaded. So this represents 4/5. But this is quite interesting, and it takes us, helps us start to think about what we're going to be learning in this lesson. We have these boxes, they comprise of 6 boxes each, but here we can see the whole 6 boxes are shaded, and here 5 are shaded. So we can represent this as one whole box because everything is shaded, and this one represents 5, 6. But if you think about it, we actually have here another way of writing this fraction, and we call that improper fraction. I'll repeat, improper fraction. Sometimes some people call it top-heavy fraction. Why do we call it that? Look at these fractions. You can see that we have smaller digits on top. They are smaller numbers. Normal fractions have smaller numbers on the numerator, smaller numbers on the numerator. But here, you see that it's top heavy. It's bigger. The numerator is bigger than the denominator. So we'll call it top heavy fraction or improper fraction. This is proper fraction. Okay. Next one, you were asked, fill in the missing values to make each statement correct. Now, to make this statement correct, we know that if we had 7 here, this number would be equal to 1. So that would be equal. But we're looking for something that we would write there to make this statement correct, which means it has to be less than 1. So that number has to be less than 7. So we write x less than 7. Here, we have to look for a number such that whatever that number is, if we divide this fraction or work out this fraction, it has to be bigger than 1. Of course, we know if that number were 5, this would be equal to 1. But this is showing us that we have to put something there that would make this greater than 1. So that number has to be greater than 5, because if it were 5 over 5, this statement would not be correct. Let's do some new learning. Look at this, number line. Okay. Now, if I ask you, have a think, how would we complete this? Well, you would say, yes, we've done this before in our previous lesson. We have 3 intervals and we have the difference between this, all right, is 0 and 1. So we're going to be dividing 1 by 3. So it's 1/3, 2/3, and 3/3. But we know that these intervals are all equal. Sure. How do we complete the other parts of the interval, of the number line? You say, well, it's going to keep going up in thirds. So the next one has to be 4/3, 5/3, so on and so forth. Now, this other part, if we had to complete this, we'll say, well, it has to be the same, right? But what if we say, well, let's write the numbers on this part of the number line, let's write it as a mixed number. So mixed number means this one that we saw in our retrieval practice. So this number here is called a mixed number. It has a whole number on the side and a fraction to the right side of it. A whole number on the left and a fraction to the right side of it. Do you remember what this is called? Top-heavy fraction or improper fraction. Let's go back to what we're doing. So now, if we complete this, we're going to write 1/1/3. Why? You can see here that this is 4/3. This one was 3/3, which is equal to 1. Now, 4/3 has to be after 1. Remember, the fraction is increasing by 1/3. It has to be 1 and 1/3. The next one will be 1 and 2/3, right? Because it increases by 1/3 every time, and so on and so forth. Now, let's move on. What you've learned so far is that you can write fractions that are greater than 1, but you have to acknowledge, you have to know that these fractions, you can write them as mixed number. Remember, you have to write them as mixed number, so the whole number is to the left of the fraction and the fraction is to the right of the whole number. And then you can also write it as top-heavy fraction where the numerator of the fraction is greater than the denominator. Okay, it's now time for you to use your little knowledge to answer some of these questions so that by practicing, you can really understand what you've learned and how to make use of that knowledge. So pause the video and answer question 1 in 2 minutes. All right. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. So here you were simply asked to continue the number line. Okay. So it's a quick, fairly straightforward, question. Here you can see that it's increasing by 10%. So you just had to continue the number line. Pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. Here you were asked to complete the number line. So this is similar to the example we did in the first part of the lesson, which we're still carrying on. So here you simply, these are in top heavy fraction form and these are in mixed number form. And you can see that they increase by 1/5 every time. So that will be 1/2/5, 1/3/5, so on and so forth. You can see that this one is 2. Why? The next one will be 1/5/5, 1/5/5. Okay, which is obviously, 5/5 is 1. So it's a bit like saying 1 and another 1, which is 2. Okay. And then here you're told to use the number line to convert the following. So using the number line, we can simply see that this is 7/5 and we can use this to complete it. This is 11/5. Why? Because it's just going to be 2/1/5. It's just like continuing the number line, trying to extend the number line more than it was shown in the diagram. Pause video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered the question, here are the answers. Let's discuss them. Here you were asked, the number line shows the calculation 2/3 plus 2/3 plus 2/3 plus 2/3. Right. How many thirds are there altogether? Remember, in 2/3, we have 2/1/3. So if you think about it, we have 2/1/3, another 2/1/3, which is 4/1/3. And if we group that one, you see that we have 8/3. All right. Now, have you noticed something? You could have simply worked this out really quickly. Now, I'm not giving something away, but I want you to notice something. We could have simply just added 2 plus 2 plus 2 plus 2, which is 8/3. So the number in the denominator remains the same, but we simply just add the numerator. Think about what I've just done. Think about it. Don't forget about this, what I've just done, about another way of working this out, because when we start to work with fractions in future lessons, you're going to be thinking, wow, I get it now. That's why we did what we did. Right. Okay. Question B, you were asked, complete the calculation. So you have 8/3 and then you're required to write it as a mixed number. Now we have 2/1/3, and then of course we're going to have 2/3 left. So as a fraction, as a mixed number, we can write the calculation like this. All right. So let's move on. If I ask you to write this as a mixed number, how would you go about it? I'll give you a hint. If we group these quarters in groups of 4, what will 4 quarters give me? What number? Well, I think you would have said is 1, right? So if we group these, we'll have 1, 2, which is 2¼ So this here is 2¼ And we actually have 9 quarters. So we have 9 quarters. So there's something I want to show you. This is really cool stuff, right? So when you start to study higher level maths, you think, okay, 9 quarters. Well, we could have written it like this: 9 quarters. We have 9 quarters. And it's the same thing as this. I want you to take note of this, how we split this into this, because it's a really cool way you can do other things with maths. Okay, it's a really cool, there are so many things you can do once you know that, well, 9 quarters, 9/4 is same thing as 9 lots times 1/4. All right. There are so many cool things you can do with it, even when you study maths at A level. That is if you want to be a maths professor, which I would like you to be. Okay, let's move on. Now that you've learned about that, I want you to try these. Pause the video and answer these questions in 2 minutes. All right, assuming you've paused the video, check this out. If we want to write this, we can say, did you remember what I showed you just now, right? This, we can say we have 5 lots of 1/3, right? Remember what I told you about how we can actually break this down and really think about what's going on. So we can say, well, I have 5 lots of 1/3. But if I want to group the thirds into what will give me a whole, I actually have these groups of 3, because remember, a third and a third and a third will be 3/3. Yeah? Remember what I showed you earlier? We could write this, if we are grouping these thirds, we could write it like this. We could say, well, if I have a third and a third and a third, I'm grouping them, what will it give me? Remember what we did earlier? We could simply just keep this like this and we say, oh, 1 plus 1 plus 1 is 3. Oh, it's 1. But this is not up to a whole 1. This is 2/3. So actually, this is 1/2. Okay? So I want you to really take note of this, because you can do a lot of cool stuff in maths just knowing this, this way of thinking about it. All right. So actually, this is 1/2 as a mixed number. I hope you haven't forgotten. So this is a mixed number. You have a whole number on the left and you have a fraction written to the right side of it. What about this one as an improper fraction? You may be thinking, okay, how many fifths? Because you can see that it is a whole and 4/5. So thinking backwards, you're thinking, all right, how many fifths? Because remember, we always use the denominator to express the fraction we're really talking about. How many fifths would you have had to make 1? You say, okay, I get it now. It has to be 5/5. So 5/5 would have given me a whole. Okay. And then you say, well, if I have 5/5 and I have 4/5, well, that makes 9/5. So as an improper fraction, this will be 9/5. That is one way of thinking about it. Another way of thinking about it, you say, okay, this whole one here is actually a whole box. And we know 4/5 can be written as, a box that is split into 5 boxes, little boxes, and then we shade 4. So now we say, well, why don't we make everything look uniform? So if we have split these boxes into 5 equal parts, let's do the other one like that. And then you begin to see that, okay, we have 9 shaded, which is 9/5. So as an improper fraction, this is 9/5. But I like to think about it the way I explained it before I explained this method. Think about, okay, I have a whole number here. How many fifths would I have had to make this whole number 1? So you say, oh, okay, it has to be 5/5. So if I have 5/5 and I have 4/5, so as an improper fraction, this is actually 9/5. All right, let's look at a further example. Before, I know you're thinking, oh, I really get this. I want to do some practice questions. Hold on, hold on. Right. If we have a red trapezium, a yellow hexagon, a triangle, a green triangle, and a blue parallelogram or rhombus. Here are things we can use it to answer. So 2 triangles fit into 1 rhombus. 3 triangles fit into 1 trapezium. How could you use that information to answer this question? Have a think. What will you put here for this statement to be correct? So dash trapezium fit trapezia. So trapezium is for 1. Trapezia is for many. How many would you fit into the hexagon? Well, I'm sure you wrote 2, right? Because 2 of these will fit in there. And then for the rhombuses, how many would you fit into the hexagon? Now, remember the statements and how these are linked. Of course, 3. So 3 rhombuses would fit into 1 hexagon. Let's look at a further example working with shapes. If the rhombuses represent 100%, so these rhombuses, they represent 100%, that's the rhombus. What does the whole diagram represent? What does the whole diagram represent? So remember what we did earlier, how many of these fit into each other. Now, if you think about it, if that's 100%, then we need 3, this has to be half, because remember, this one, 2 of this fits that. And then this, we know 3 of this fits that. So we know that has to be 150. And we know 2 of these fits that. So that has to be 300. So altogether, we have 750%. It's now time for you to do some practice. We've done a lot of learning in this lesson. Well done for being patient and for sticking around. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. So here you were simply asked to use bar models to convert mixed numbers into improper fraction. So these models show that 2 3/4, so you can see 2 3/4, yeah, is equal to 11/4. So use Kim's method to convert mixed numbers to improper fraction, and you can see it here. All right. So this, we know that you're still thinking, okay, we have half. How many halves do you need to make 3 wholes? Yeah. How many halves do you need to make 3 wholes? 2 halves will make a whole. So if you're making 3 wholes, 3 full ones, you need 3 lots of those 2 halves. So which is 6. And you have another half here. So that's 7 halves, which is 7/2. So you can write, remember how I showed you? You can write that as 7 lots, so times a half. And then look at this one here. You can apply the same knowledge here. You can say, okay, how many quarters do you need to make? So this one. So how many quarters do you need to make 2 wholes? So we know we need 4 quarters, 4 quarters to make 1. So 4 quarters give us 1. Now we need 2. We need 2. So to make these 2, we have 8 quarters. So 8 quarters gives us 2. Right? 8 lots of quarters give us 2. But we have extra 3 here. All right? So altogether, we have 8 plus 3 quarters. That's 11 quarters. Right? I like you to think about it like this because it's a very good way of thinking about how you split fractions into their component parts of what is really going on, because you can do cool stuff when you start to study maths in your further learning of maths. Okay. All right. Let's move on. Pause the video and answer question 5. So we're done with 4. Answer question 5 in, sorry, answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. So question 5, you were asked convert the improper fractions to mixed numbers. So by now, you should know how things really work. So here, thinking about it, you say, well, we have 11 thirds. So how many thirds will I be able to get? All right. So if I have 11 thirds, how many of those groups of thirds will give me a whole? So every 3 groups of thirds will give me a whole. Every 3 groups of third. So I can have a group of third, another group of third. So 3, 3, and 3. So that's 9. So 3 groups of thirds will give me 3 whole. All right. 3 groups of thirds will give me 3 whole. So I'll be left with 2 because remember it's 11 thirds. So that will be 3 2/3. All right. Here, the way to think about it is say, okay, how many 6 will give me, how many 6? If I have 30, 1 6, 1 6, 1 6, 1 6, 1 6, how many 6 will give me a whole? You say, well, I need groups of 6. 1 6, 1 6 into 6, 1 6, 1 6 into another 6. So I've used up 12, right? So you say, oh, okay, so that's 2 whole. I'm left with 1 6. So that will be 2 1 6. So I want you to start thinking about fractions like that, and you begin to see that, oh, it's really easy. It's not difficult. All right, so mark your work, celebrate your success. Well done. Question 6. Pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. So here you're asked if the hexagon represents one whole, what fractions are represented? So you can see, all right, thinking about it, we've done this in the example. So this should be a really straightforward answer for you to get. So mark your work, celebrate your success. If you got it wrong, do not worry. You can learn from your mistake. You improve, you get better as you learn from your mistake. So well done. Well done for sticking around. You're doing very well. Pause the video and answer question 7 in 2 minutes. Here are the answers. So here the question is, the nth term of a sequence is given by the rule 4n over 5. So 4n divided by 5. Write the first 6 terms of the sequence. Give your answers as mixed numbers. You say, oh, I get this. What's really going on? So it means every time we are having to increase by, what do you think? Right? All right. So the first one is 4 over 5. So the second one will be 4 times 2 over 5. All right. So you say, wow, but I haven't seen this before. What's going on here? So you say, well, that's the first one. First term is number 1. Second term is number 2. So you say, okay, 4 times 2 over 5. So that's 8 over 5. Oh, so I get it now. How many fifths can I get out of this to get a whole? You say, oh, it's just 1. Just need 5 groups of 5 fifths, and then I'm left with 3. So that's 1 3/5. You say, okay, what about the third one? Okay, it's going to be 4 times 3 over 5. Oh, you say, oh, I get it. It's 12 over 5. How many fifths can I get from here? Oh, you say I need, 5 fifths will give me a whole, so I can get 2 groups of 5 fifths. So which is these 2, and I'm left with 2 fifths, because if I get 2 groups of 5 fifths, that will be 10 So I'm left with 2/5. And that's what I did here to get all these, right? So this one will be 4 times 4, because that's the fourth position, yeah, divided by 5. So that's 16/5. Okay, and you say, oh, okay, I get it now. So that's 3/1/5. All right. Okay. So those are the answers. So mark your work, celebrate your success, and well done for sticking around and for working really hard in this lesson. So you're working at some higher level stuff. Okay, this is higher level part of your year 7 work, but I'm going to say well done. You've done really well. So that brings us to the end of our lesson and to the end of year 7 term 1. Okay, year 7 term 1. So what we've learned so far is you've learned how to write fractions that are greater than 1 as mixed numbers, and you've also learned how to write them as improper fractions or top heavy fractions. Until next time, take care of yourself. Well done for working hard, and bye bye.